Here we are going to learn about the chemical properties of benzene. So first is addition reaction. Addition reaction. If we add hydrogen, right, in the presence of platinum, palladium or nickel, what do we call? We call that to be also a reduction, okay? We will also call that to be a reduction of the benzene. So what I do, I take a benzene, this is the benzene structure, there is alternate double bond into it, and if we do the hydrogenation, we will require 3 moles of this in the presence of platinum or nickel or palladium, and temperature will be around 473 to 573 Kelvin. What will happen? The reduction means what? There is a hydrogen, no? Everywhere there is a hydrogen. This is the bond line structure which we write for the benzene, and these are the hydrogens which are present. So there are altogether 6 hydrogens over here, one, like everywhere there will be hydrogen will be added, and this will be also called as a reduction reaction. Means what we are getting after this is this, means these are the hydrogens, these are the carbon, and on each carbon there is a hydrogen. Right. These are carbons. I will just show this also. These are carbons. Okay, in short, we show it in this form, cyclohexane. This is cyclohexane. If we do the chlorination, next reaction, okay, this is the addition reaction because double bond is changing to the single bond over here and hydrogen is being added, and just there is a addition, like there were 6 hydrogen, now there are 12 hydrogens over here, so there is an addition of the hydrogen, C6H12 is the formula for this. Next is halogenation reaction. If we do the chlorination, take benzene and add chlorine molecules, like this will be going via free radical. Here there is a H nu is a light that will break the chlorine bond, and finally you will get hexachlorocyclohexene. Okay, that is what the compound you are going to get over here. These were all the addition reaction. Okay, first we did with addition of the hydrogen, then we did with a chlorination. Now let us understand substitution reaction. Under chemical properties, what we are learning is next a substitution reaction. Substitution reaction. Since benzene is electron rich, there is pi electrons, alternate pi bonds are, then we consider that to be a benzene to be electron rich. So since benzene itself is very electron rich, electrophilic substitution will be readily possible on this benzene. Means what we are learning over here is mostly a electrophilic substitution, all the electrophilic substitution on the benzene. So it is first what we will be learning is halogenation. Let's take this halogenation. Let's take Cl2. Cl2 will be added to this compound. You take a benzene and add chlorine in the presence of FeCl3. Okay, FeCl3, and what you get will be the chlorine which will be substituted on the benzene. Now think about this. See, chlorine is the molecule and how it is an electrophile. So what happens in the mechanism of this, the mechanism for this is step 1. Step 1 is a generation of an electrophile. It is a generation of an electrophile. Electrophile will be generated at first. How? See, this is a chlorine and this is how the bond between chlorine exists, and this is FeCl3. Right? See, there are 3 halides which are connected to it and it is an electron deficient. This will have a very strong inductive effect, and also octet of the Fe is not complete. What we say is that this is FeCl3 is in need of electrons. So FeCl3 over here is acting as a Lewis acid which is in need of electron, accepts a electron pair. So this is a Lewis acid. So after reaction between this and this, you will get a Cl plus. This bond will be broken over here and it will be donated to this. So you are getting a Cl plus and FeCl4 minus. This is what is your electrophile. This is your electrophile. It's not over here at. Next is, I'll just clean this part. You can make a note of these things because I want to write step 2 over here. Okay, you can pause video for some time and make a note of these things. Yeah, I'll write step 2 over here. Step 2. This is a part. It is substitution of electrophile. Now what is the electrophile over here? This is your benzene. This is your benzene. And electrophile is Cl plus. We are doing the chlorination. See, electron rich always attacks the electron deficient. That is the basic idea about any reaction. No? So this is the electron rich part. This will be donating. It can donate an electron. This is a pi bond. It can break in this manner or it can break in this manner. Let's say it is breaking in this manner. Then this carbon is going to lose its electron. Means attack will be shown this way. And this chlorine will be there. And here there is a positive charge which will be generated because this, while forming this bond, this carbon is losing its electron, right? So this is the thing. Now what has happened in this substitution? The aromaticity, like benzene is aromatic and the aromaticity of the benzene is disturbed. Okay, so the stability, benzene has lost its stability. So to regain its stability, what will happen is that like on every carbon there is a hydrogen, but we don't show. So I will show this one hydrogen, right? There are hydrogens here also which we don't show in a bond line structure. So this is that hydrogen which I am showing. Why I am showing? Because I want to show how it donates electron to this positive charge and make it more stable. So this is going to donate its electron over here and this hydrogen will go as a H plus. So further what I get is this chlorobenzene plus H plus is gone. So this is chlorobenzene and this is a substitution reaction. To whom what is getting substituted? What this substitution means, one group should be replaced, no? So over here hydrogen from one of the hydrogen from the benzene is being replaced. That is what the electrophilic substitution in under substitution reaction, electrophilic substitution reaction, it was a chlorination reaction. So this will be a process, electrophile will be there and it will be substituted. Then every time this hydrogen will be left to stabilize the positive charge which is being formed over here. Any electrophilic reaction, any electrophilic substitution taking place in benzene, it will go with this mechanism only. So we are doing a substitution reaction, and what we are substituting everywhere is an electrophile. So electrophilic substitution reaction. So next I will write is nitration. Nitration of benzene. The reaction is so simple. You take a benzene, nitration means NO2 I need to add. So HNO3 is a very good source of NO2 in the presence of acid. It will be written as a H2SO4 or as a just H plus sometimes. And this is 333 Kelvin. What you are going to get is a group this way, NO2. This is nitrobenzene, which is you are going to get nitrobenzene. Right? This is the nitration reaction. Now, how the electrophile is being generated over here? So, I will start mechanism. Mechanism of this is this way. First is generation of the electrophile. Step 1. Step 1 is generation of an electrophile. How do we generate? What is that? There is a HNO3, right? Structure of a HNO3 is this way. Double bonded O, here there is a minus, and this is OH. So in the presence of acid, since there is an acid, it is a very good source of a H plus ion. It is a strong acid, H2SO4. So here I will write this H2SO4 is a very good source of H plus ions, right? So H plus ion is there, and this is the electron rich part. It will donate here, and there will be there is a positive charge on this also, positive charge, and this is also a positive charge. Now having a positive charge on electronegative element is unstable, right? So what is going to happen is this bond is going to break in this manner. It will be donated, and what you will be getting is further NO2, right? NO2, and nitrogen is losing its electron, so plus NO2 plus, and other is H2O. So electrophile is generated. Next is step 2 is addition of electrophile, and it will follow same step as we did in the first reaction, halogenation. So this is your benzene, and you are taking NO2 plus as an electrophile because this was the electrophile which is generated. Okay, if you do the substitution of this, then positive charge, and here is the NO2, and there is a hydrogen, and this is how the nitration is going to take place. What is substituted again? The hydrogen is replaced and NO2 is substituted over there. So this is next.